Here's another video for my GCSE students revising logic gates. This time we're going to do the logical OR gate. I'm going to use a 2-input gate with the inputs A or B. And if you notice, quite important now, it almost looks spaceship-like. It's got that curved side on the inputs. That's really important. Don't make it flat. If it looks flat, people are possibly going to get confused with the AND, so you don't want to do that. So a nice curved, almost spaceship-like, and the output will be, in this case, I've called Q. It could be called something else if you want. Let's draw a truth table. So B and A are our inputs. The output is named Q, and I'll just run through all the possible inputs. So 0, 0, 0, 1, 1, 0, 1, 1. Now the output Q will be true if any or all of the inputs are true. So it's an inclusive OR. This is also known as an inclusive OR. So fully inclusive, doesn't matter if any of them are true, then the output will be true. Well, in the first situation here, none of the inputs are true, so the output will be true. But in the remainder of these different input combinations, we've got one of these. A in this case is true, so the output will be true. B is true, and A is false, but it doesn't matter because we only need one. It's an OR. And then in this case, both of them are true, but no problem. So if any or all of them are true, the output will be true. That's the completed truth table. Now, if we were to write this out algebraically, we would say that Q equals A or B, but we prefer not to write it that way, or at least we shouldn't be writing it that way. We should be writing A or B, like that. Now, we use the plus operator here, but in this context we read it as OR, so we say A or B. And perhaps it makes a little bit of sense, not entirely though, but let's just consider this. So 0 plus 0 is obviously 0, 0 plus 1 is obviously 1, or 1 plus 0 is 1. The only case that this actually falls down is when you've got 1 plus 1, you're going to say, well, that's 2. Well, in this case, it's actually 1. So it's a little bit like we were some primitive life form and we could only count from 0 to 1. So as soon as we got to 1, that was it. That was like that was the extent of our counting. So the plus operator we need to read as OR, so never say plus in this case when we're talking about logic operations. And that's all you need to know for the OR gate just for the moment. It's also known as the inclusive OR.